working on 10.4 using square roots to solve quadratic equations. In this course, solutions refers to real number solutions. We know there are imaginary numbers out there, but all we will be working with are real number solutions. We are going to solve equations by using square roots, and we start out with an equation where we have to get x squared all by itself. That means that we must divide by 3 on both sides. When we do so, we have x squared is equal to 9. Our goal is to, in the end, get x by itself, and that means I have to undo squaring. We undo squaring by square rooting, and so the square root of x squared is x. The square root of 9, we know the principal square root is 3, but we need also the secondary square root. We need all possible square roots of 9, so we need a plus minus 3. Here we have adding of 12. In order to get p squared on both, all by itself, we need to subtract 12 on both sides. That leaves us with p squared equals 0. Undoing the squaring by square rooting gives us the square root of p squared, which is just p, and the square root of 0, which is only 0. There is only one square root for 0. This is a special case. A squared minus 3 equals negative 4. We are going to add 3 to both sides, and when we do so, we find out that a squared equals a negative 1. If you think about the squaring a number and equaling a negative, that can't happen. Even when we take the square root of both sides, we know the square root of a negative number is not a real number, and so we write no, and if you want to write real in there, that's fine. There is no real solution to this problem. No solution will be just fine for me because of that negative under the radical. Working with fractions, we have to get x squared all by itself, so we will divide by 25 on both sides. This leaves us with x squared is equal to 49 over 25. And again, we are taking the square root of both sides. The square root of that fraction is the same thing as the square root of the numerator over the square root of the denominator. So when you are writing your answer, you will have 7 over 5, and don't forget, we need a plus minus sign in front of that. Square root of 49 over 25 is a plus minus 7/5. Why do you get two solutions when you take the square root of each side of the equation? Because for a positive number, there are two values. One is positive and one is negative. You must get both as you are solving an equation. Let's also approximate solutions of a quadratic equation. This is a multi-step problem, and in order to get x squared all by itself, we need to follow our order of operations. We'll have 2 squared equals 16. We'll divide by 2 on both sides and end up with x squared is equal to 8. When we take the square root of both sides of the equation, we know that 8 is not a perfect square. So on your calculator, punch in 8, take the square root. We'll round our answer to the hundredths. You will get 2.83 rounded to the hundredths. Put a plus minus in front of that, and you have the approximate solution for this problem. Solving with a binomial in there, we're going to do the same idea. We have to get the binomial by itself. So we're going to divide by 4 on both sides, and we have x plus 6, quantity squared, equal to 8. Square rooting is the way to undo a square, and so that leaves us with x plus 6 equal to a plus minus 2.83, because we are taking a decimal of the square root of 8, and then we have to subtract 6 from both sides. And when we do so, that leaves us with x equal to a negative 6 plus or minus 2.83. You will do both equations here, negative 6 plus 2.83, and x equal to a negative 6 minus 2.83. The second one is easier to do because they're both negative. You can just add your two numbers together. The first one, you need to follow your negative and positive rules and end up with a negative 3.17. You will have two answers for this problem, one for each set. Here we have a vertical motion problem, dropping a towel from a balcony 18 feet above onto a table that's 3 feet above the ground. How long is the towel in the air? Please use h equals negative 16t squared plus vt plus s as your vertical motion formula. And substituting numbers for the different variables, h is our height that we want to know the time for. We want to know the time for when it hits 3 feet above the ground, so we're going to put 3 in for h. Negative 16t squared, we want to find out when it actually hits the ground, so we want to find t. Velocity, if you're dropping the towel, that means you give no velocity to the towel, so we put in a 0. And it starts 18 feet up in the air. We start simplifying this problem by subtracting 18 on both sides so that we have getting our t squared all by itself. That leaves us with a negative 15 equals a negative 16t squared. We will divide by a negative 16 on both sides. And since we are approximating this one, because we're rounding our answer to the nearest hundredth, we will divide 15 by 16, and we come up with 0.9375, and it's positive, equal to our t squared. And now we must take the square root of both sides. We'll square root both of those sides, and we're going to end up with 0.97 plus minus as our answer, and that is rounded to the nearest hundredth. But we only want to keep the positive answer. We don't want negative time, so we're going to write it as 0.97 seconds only. We will only put one answer in our box. Thank you.